Station, this is Houston. Are you ready for the event?
Houston, this is Space Station. We are ready for the event.
National Science Foundation, this is Mission Control Houston. Please call station for a voice check.
Station, this is Sethuraman Panchanathan with the National Science Foundation. How do you hear me?
Hey, we hear you loud and clear. It is so great to talk to you today.
It is truly a delight to talk to you today, astronauts Rubin and Glover. Thank you so much for your time today. It is indeed exciting to talk to you both. My name is Sethuraman Panchanathan, and people call me Punch, and you know why. Is it okay to address you as Kate and Victor moving forward?
Absolutely.
But, by the way, we have a common friend and a 5-time astronaut, Ellen Ochoa, who is a friend and a colleague and a chair of the National Science Board. Ellen and I were talking about you both just yesterday, how excited she is that you're both doing the work that you're doing at the ISS. I tell you, Kate, you are a huge inspiration to millions of children who aspire to be astronauts. You're the first person to sequence the DNA in space. Wow, what can I say? It would be great if you can share the STEM spark that kids, for example, like my new granddaughter, Anya, can be motivated by.
Absolutely. It sounds like your granddaughter Anya is already off to a great start if she's excited about science. When I was about 12, my dad actually took me to a conference on recombinant DNA at the Exploratorium in San Francisco. And I just thought this was the most fascinating thing. And that's a great age to get, any age is a wonderful age to get kids involved in STEM. But right around 11, 12, they start thinking about what they might want to do as a career. And just that little bit of science exposure, one conference, one experiment, that kind of thing, it absolutely sparked my interest. And I said, well, I want to work on DNA and recombinant DNA. I just didn't know I would end up doing it in space.
This is fantastic, Kate. What an amazing inspiration. I tell you, Victor, it's truly amazing to watch your life journey. I was reading about it and I'm like, wow, again. Thank you for your service to the nation, first of all. It's just phenomenal. We are very grateful to you, sir, as a nation for your service. I was interested, what got you as an engineer interested in being an astronaut? Again, you could also add your words of wisdom to the young aspirants out there who are looking to you both as amazing exemplars.
Well, first of all, congratulations on the granddaughter, and I, like Kate, at about 11 years old, I had a 5th grade teacher who, he knew that I liked math and I needed a little bit of motivation, and he told me that if I worked hard and kept developing those skills that I might make a great engineer one day. Mr. Hargrove at Allison Elementary School, and I still to this day am trying to make him proud. And so, taking that engineering experience, and when I was in college thinking about going off and studying and pursuing a career, I wasn't sure I was ready to take the cubicle route and go fully into design. I wanted to put it into practice first, and flying and being a test pilot was a great way to do something applied. And so for me, that was a great option to use my technical education. And then the transition to being an astronaut, it was a childhood dream that was really solidified into a professional pursuit when I got to see one of our few female shuttle commanders, Pam Melroy, speak at an engineering conference. And her talk, it was the operational piece and the technical piece was amazing, but it was the way she talked about her crewmates that made me say, I'm throwing my hat in the ring. Worst they can do is tell me no.
So we are so happy as a nation for the two of you having got your STEM spark and how you took that and then built upon that. And now here you are, amazing heroes for those children that are looking to you now to get their STEM spark. So I'm so thrilled. Kate, to you again, you've been doing a lot of experiments that benefit science. I've been reading about you, amazing background for our nation and humanity. So clearly there must be a lot of challenges, isn't it? I mean, it's not that straightforward. So what do you find are some of the challenges for conducting research in microgravity about the ISS? I think people really want to hear that.
Yeah, all the things that make microgravity such a unique and fascinating environment can occasionally make it a little bit difficult to work. So we have some really interesting properties of fluids up here, but it also means if you're handling anything with fluids in it, which is a lot of biological experiments, you have to think about where the fluid's going to go. We do this kind of on-orbit centrifuge to move small amounts of fluids around, large amounts of fluids. It does allow us to study things like capillary action. So NSF actually had a really interesting experiment that was based on this idea that capillary action is much, much, much larger here. It's many times larger than we can ever form on Earth. So we can form these really big droplets of water. So these sometimes disadvantages or things that make life difficult when you're designing an experiment up here are actually the very thing and the very advantage that we want to study, for example, with the drop vibration and inertial spreading experiment.
So that's amazing. I mean, it just is so thrilling to see how you're taking the full advantage of what space can provide in terms of moving science forward, leaping forward, because of the fact that you can conduct experiments that cannot be conducted here on Earth. So, Victor, we talked about the challenges with Kate. Clearly, I mean, the flip side to that is there are tremendous opportunities. So what are the benefits and opportunities of conducting experiments in space from your perspective?
Well, as Kate mentioned earlier, we sort of run the spectrum from scientist to lab technician. And in order for a lab tech to do their job well, they need great resources and they need great guidance. And we spend a lot of time looking at procedures and working on the hands-on part of the science. And so one great benefit that I've seen in my short time here watching Kate, the pro, work is how we can make small improvements in those basic things, the resources. Kate mentioned that we do a lot of centrifuging. It is very low tech. I mean, it's just us sometimes swinging a bag or a bottle trying to make sure that the fluid goes where we want it. But also the obvious part of using a laboratory where you can control gravity. We have the ability to have things suspended and use a centrifuge to spin them at different variants of fractions of a G, 1G, 2Gs. And so having a laboratory where you can isolate gravity gives you just a unique capability to do new types of research and also new types of production to grow and fabricate things in ways that you cannot do on Earth.
Yeah, that's absolutely true. That's amazing. Kate, did you want to add anything else? I mean, you seem to... Did you have anything else to add? Can we move on to the next question?
Oh, yeah. I have a lot to add. I'd talk for an hour if you guys would let me. One of the really interesting things we talked about, fluids and microgravity, but it also allows for things like self-assembly of larger structures. So we use that from a biologist perspective to look at larger tissue structures. We can do three-dimensional tissue engineering up here. We can also do really interesting things with mixing in space. Since we don't have buoyancy-driven convection due to microgravity, we study things like colloids. We've studied tripartite hydrocarbon mixtures. There's just really interesting ways that things mix or don't mix that would be very different in gravity, and we're able to remove that gravity from the equation. Another really interesting thing up here is combustion. Combustion completely changes. So you imagine a candle burning on the ground. It's a teardrop shape. It's not up here. It's round. And so we actually do have a combustion chamber. We've got a great resource all around us, which is vacuum. And so we use the vacuum of space to do a lot of experiments. Pretty much everything is based on microgravity. Occasionally, our space radiation environment will play in, and sometimes we'll look at vacuum and thermal constraints outside the vehicle.
That's amazing. Thank you so much. So, one of the things that you guys have the privilege is viewing Earth from space above, right? It's an unbelievable, I'm sure, it's an unbelievable scenery for you looking down on Earth. So as you look at that and sort of take it all in, so how does your view of Earth from space influence what you want to learn about our planet?
Well, I think I've already had a great appreciation for culture and for travel, and seeing so much more of the planet with my own eyes and being able to see it, not like you see it on a map, but to see it in its true form, just makes me want to visit places, but not just populated places. I love culture and food. It also makes me want to go hiking and go see the parts that are not very populated, and just go spend more time in nature. And as a Navy guy who has spent a lot of time at sea, it has really rekindled my passion for the ocean. I love the ocean. The color of the water when there's no land around is just a beautiful deep blue, and it makes me want to reconnect with the water as well. And so I just have a great appreciation, and being here has made me have an even greater appreciation for the beautiful Earth.
That's tremendous. Kate, you?
Yeah, I definitely realized my first flight, when we lifted off the launch pad and were orbiting the Earth just in our little autonomous Soyuz vehicle, and I only had 10 cubic meters of atmosphere. It does strike you that atmosphere turns into a very precious resource. I've never thought about the atmosphere around me or the oxygen molecules that I'm consuming until they're extremely limited. And this is one of the things that we see from space, because we see over the horizon the atmosphere layer appears so thin. It's so delicate. It's very fragile. We've noticed this a lot. We see some beautiful signs. I mean, the aurora from up here across the whole, continent in the north is absolutely incredible. You can appreciate, geomagnetic storms and that kind of activity in a different way up here. But we always look at it, and it just strikes us how delicate and fragile it is. So I think it's something that we want to research, our Earth and atmospheric systems. We want to understand what we're doing. We see global impacts of storms. So you see these storms developing on one side of the world, and you'll watch them go to the other side of the world. All kinds of really interesting interactions. Oh, sorry, stand by.
Yeah.
We see Node 2 forward Crew Dragon Alpha.
Hi, we are back with you, and we're terribly sorry.
This is real life. That I love it. I love it. Nobody will ever think that we can this. This is so perfect.
We have a caution and warning system up here, and that was one that we had to respond to really quickly. So anyway, it wasn't an atmosphere caution, it was a power caution. But one of the things that we do really notice is all the things it takes to keep people alive. So that could be a power system fault. All of our power comes from solar arrays. Even things like water recycling. We recycle all of our water up here, and learning how humans work in a closed system and just the engineering of these closed systems is totally fascinating.
This is fantastic. This is fantastic. Thank you. Many people don't know that NSF funds ground-based astronomy, and that we work very closely with NASA. I mean, we truly value this strong and synergistic partnership between NSF and NASA. Jim Bridenstine, the recent past administrator of NASA, and I signed the MOU just a few weeks ago. We're so thrilled and excited in terms of how we can broaden the partnership between NSF and NASA. So one of the programs that NSF funds is the U.S. Antarctic program, as you may know. And two of your colleagues, Christina Koch and Jessica Meyer, spent time working in Antarctica, including wintering at the South Pole, which is an amazing experience, I've heard. I had the fortune of being in the South Pole a few years ago, and I tell you, it was an experience of a lifetime for me, which I'm sure is how you feel every day about the ISS. So I can truly appreciate. I mean, it's multiple times more than what I felt. So Kate, I want to ask you, what other experiences like that, like being, in an environment like a, harsh environment like Antarctica, what other kinds of experiences would help prepare people for the demands of space exploration? Just thought people want to know, what should we want to do to prepare for such a thing?
Yeah, that's a great point that you bring up Antarctica, because that is almost one of the best analogs that we could have for space exploration. It's a harsh environment. It's remote. When people go to overwinter there, they're really committed. We've got a science focus. It's an international collaboration. I think it's probably the closest thing that we have in terms of the way that countries work together and just the pure scientific value of being able to do research in Antarctica and research aboard the International Space Station. So that is definitely one of the places that would prepare you. We also have other analog missions, and so, for example, I lived underwater for a little over a week at doing saturation diving. That's, again, very safety critical, but fascinating science environment to do work underseas. I did some field work in the Democratic Republic of Congo. It was not easy to get logistics in and out of there, and it's a difficult field location, but that's also the kind of thing, with a small team in there and everybody working together in a remote site, challenging terrain. I think these are the kinds of things to prepare us for future deep space exploration.
Thank you, Kate. Victor, I was going to ask you, what do you think we should be doing to get ourselves ready? I mean, you're ready, man. You get yourselves ready for exploring the moon and the Mars. I mean, I just want your perspective on that. I mean, it's just fantastic to watch you there. So give us some insights in terms of what do you think we should be doing to get ourselves ready for that?
Well, I'm going to pick up on what Kate was saying. Those types of experiences that you work with a small team in a high-performing environment where you have to focus on mental and physical toughness, I think those are important qualities to develop. But there's also a piece that I think does not get as much attention that I like to focus on, and that is the resilience, the grit, the mental fortitude that it requires to do this job. So I think this time that, this pandemic that we're all dealing with has been tragic for so many people in so many ways. But I will say that it is a little bit like the preparation we do for these types of missions, and it is a small, there's some relation to getting ready for these kinds of missions, or actually being here or wintering over in Antarctica, dealing with the physical distancing and having to find creative ways to foster relationships and to entertain and to educate and to still have some type of a social connection. And so I think that this time that most of us are worried about trying to hurry up and get through and get to the other side of, it's also a time that we can reflect on our priorities and make sure that we're getting the most out of it, because it is teaching us some things about ourselves. And those are the types of things, especially for the young folks who are going to be the ones that get us to Mars. Those folks are going to have to make some serious life decisions to prepare for those missions. Being away from the planet for 1, 2, maybe 3 years at a time, that is a major life impact.
Oh, that's fantastic reflection there. I tell you, it has been an amazing opportunity to speak with you both. Time is flying, no pun intended. So I have one last question for each of you. You both will be clearly heroes. You are already for the current generation and the next generation. No question about that. I want to ask you, who is your personal science hero? Victor, why don't we go with you first?
Well, my personal science hero, I don't know if he knows it or not, is Francis Collins. And I actually got a chance when I was here in 2016 to talk to him. And he also mentioned that he was going to have some serious credibility with his grandchildren for talking to the International Space Station. We were able to do a really wonderful event at NIH when I returned post-flight. We did a National DNA Day. So it's one of the good things about space is sometimes you really do get to talk to your science heroes. I was kind of awestruck for like the first 5 minutes, and it took a while to get over that. We had a great conversation.
So Victor, what about you? Science or engineering hero for yourself?
I have a list of names that I could read off, 1 or 2 or 3 of them, but I have to actually highlight 2 groups of people in response to this question. One is all of the folks, the medical researchers and the healthcare workers that are out there trying to get us through this pandemic. Everyone that's out there trying to heal the world, those folks are my heroes right now. And I think everybody understands that. The resilience and the courage that they show every day putting on those uniforms, going to work, is amazing. And I salute them. And I also salute equally the sanitation workers that help keep our communities clean, because if it wasn't for them, none of us would be able to go about our daily routines. And so my hat's off to those folks that make it so that we can have healthy communities.
Victor, so beautifully said, so beautifully said. We have to be so grateful for all those amazing heroes that we have every day who are getting us, pulling us through this pandemic of a lifetime. So very, very well said. I want to extend both of you an invitation to come and visit us at NSF. When you're back on ground, we would love to have you share your stories, not only in space, but back on ground, and then talking about it with all the folks at NSF. And for folks outside, we'll tune in. So Godspeed, stay safe, stay healthy. Look forward to seeing you all in person soon. Thank you so much for your time today. You've made this a wonderful day for all of us. Bye-bye.
Thank you so much, too, and we heartily accept.
Thank you.
Station, this is Houston ACR. Thank you. This concludes the event.
Thank you to all participants from the National Space Science Foundation. Station, we are now resuming operational audio communications.
All right, Aki, thanks so much.